Students, welcome to part B of the introduction slides. And here, I think we're going to finish off with just slicing of numpy array. What is slicing? Slicing is when you're basically taking a subset of a data container. All right, that's basically it's taking a subset of a data container. And that makes sense. Listen, when data science, right, my ABI students, you remember Miller's Law, there's only a certain amount of data that we can parse through in our minds or make a decision off of. Right? We need to take a subset of data. We need to summarize the data, take a subset of the data. That's the only way we can really work with the data. Other than that, otherwise you get inundated, you get overloaded with numbers and values and data, and you won't be able to do any kind of analysis. So let's start with, we have our a numpy array, right? Remember the second value is 2. Let me actually rewrite this. So boom, our a numpy array is now back to being 1, 2, 3. And we confirm that it's 1, 2, 3. Alrighty. Slightly bigger. I could have made this actually bigger. Oh, sorry about that, guys. All right, so here I want to, let's go ahead and slice using the colon. There's 2 ways to slice. There's a methodology called colon slicing, and there's a methodology doing with an extra bracket and comma. For my ABI students, again, that would be the C parentheses methodology. That is the, I mean, the analogy here is the C parentheses from R is basically an extra bracket and comma in numpy. So let's start off with a bracket 0 colon 1. Oops. All right. I go ahead, I run this, and as you can see, I get the value back of just 1, right? Of 1. Why? I did 0 colon 1. My ABI students, you're now thinking to yourself, wait a minute, 0 colon 1, that should be at least the first and second position. What's going on here? What's going on here is that Python, when you do colon slicing, okay, the first value is inclusive. The second value after the colon is exclusive. So it will give you all the values up to, but not including, the 1. That is why we only got 1 value back. We got 1 back. We got 1 back as an array. Now, why does Python do this? Now, here you guys could be raising your hand and asking, give me different answers. My answer I always like to give is because Python is stupid. I don't understand what purpose this serves to have the second number as being exclusive. I don't get it, except you're just trying to thumb your nose at, I'm not even using that statement correctly, if you're just trying to spite R at this point. I don't understand what the point of this is. Nevertheless, this is how Python works, and this is actually one of many interesting differences between Python and R, between numpy and R. All right, so if logically, if we were to take that a step further and we did 0 colon 2, right, now you'll see I get the subset value of 1 and 2. Why? Because I get the 0, the 1, but not the 2. It gives me the 0, the 1, but not the 2. It is not until I do 0 colon 3 that it now gives me the 0 value, the 1 value, the 2 value, 0 position, 1 position, 2 position, and up to the 4th, which is 3, but not including the 3, right? But not including the 3. But here's the nifty little thing about the colon. I only have 3 values, but let's say I go all the way up to 4. Is this going to give me an error? It will not. The colon is very forgiving. So this will give me the 1 value, the 2 value, the 3 value. So I'm sorry, it'll give me the first position, the second position, the third position. And now I have a 3 in there. 3, the 4th position is fair game. There is no 4th value though. If I were to type a bracket 3 here, and if I were to run this, you get an error. You get an error. But nevertheless, when I do the slicing, slicing is very forgiving. I can put in any number I want. It'll give me up to the values that exist. So even if I put in 0:40 over here, there's no errors. It'll simply go, okay, give me the 0th value, the 1 value, the 2 value. Oh, there's no more values? Okay, that's it. Then that's all I'm giving you back to you. It's not going to give you an error. It's just going to give you back all the values that exist. So the colon is very forgiving. 1:1, what is 1:1 going to give you guys? If I did this, what's this going to give you? It's going to give you the first value, but exclusive of the first. It's going to give you whatever's in the one value, one position, but not including what's in the one position. Basically, it gives you back nothing. See that? Why? Because that second colon part is saying nope, 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 exclusive, exclusive. It doesn't matter. It overrides the fact that you're saying, hey, up to this point, from this point up to this point. That second point is exclusive. This is strange. This is Python. You just have to get used to this. This is numpy array. You just have to get used to it. It is exclusive. All right. And likewise, the starting position could be anything. The ending position could be anything. So if I did 1:3, right? Just copy that. 1:3. What's it going to give you? It's going to give you the second value, the third value, but obviously there's no fourth value. So it's going to just give you 2 and 3, right? If I do, and again, it's 1:4. If it's 1:4 as well, it'll give you the same results again, because the colon is very forgiving, right? It gives you 2 and 3 back. Again, we're taking subsets of the arrays here. So in situations like this, also, we don't have to, if we want all the values, let's say I do here :2, :2, right? So now, notice what it gives me. It gives me, when you have a colon there, if you have nothing to the left of the colon, that by default is saying, give me the first value. Put a 0 in there. And so this is why a:2 is going to give you the values 1 and 2. It's going to give you the first value, 1, second value, 2, up to whatever is in the third value, but not including it. All right? And that's why you don't get the 3. Same way if I have one value here, let's say I put a 1 here, and I do a colon, and after the colon, there's nothing there. This by default is again saying, give me everything to the end. So this way, the 1 stands for the second value, so I'm gonna get a 2. It's gonna give me everything up to the end, 2 and 3. All right, so that's what happens if a number is missing. It just goes by to the default, either the beginning or the end. And let's say hypothetically I have a bracket just colon. There's no beginning or end. All right, this basically means, hey, give me from the beginning, give it to all the way to the end. All right, from the beginning all the way to the end. So that's how the colon and these numbers come into play when you're doing slicing. All right, now there's, just like in R, there's nifty little functions in Python. There's nifty little functions in Python, in numpy array. So the second most function we use, probably after array in numpy, is arange. And obviously there's a range function in lists, but it's for numpy it's arange. A for I guess they want to make a difference for arrays. A for arrays. So a range of arrays. All right. So let me just copy this. And what does this do? What does arange do versus array? Well, this now works like our sequence function. We start with the 0 from a sequence, sequence from R, guys, from any of my ABI students. We start with 0. We go up to, but not including 10. Remember, the second value being omitted, exclusive, is still in effect. This is a theme that will haunt you throughout numpy and pandas. And this third value is telling you the increment we're going by. So when I run this, x will literally be the value, let me type it down here, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Starts with 0, goes up to, but does not include 10, 9, and it goes in steps of 1. And that's why you have this array, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. All right? Also, we can change the stepper and have a step by 5, right? If it steps by 5, what value we're going to get? It's going to start with 0. It's going to increase by 5 to go to 5. It's going to increase by another 5 to go to 10, except it cannot be 10. 10 must be exclusive, right? It can't have any value 10 or greater. So y will just remain 0, 5. Y will just remain 0, 5. Again, the second value here is exclusive. It'll allow you to grow the numpy array up to the number right below it. That's it. That's it. There's another cool function called linspace, and this is actually a pretty cool function because linspace, it works slightly differently. Now I showed you this because this is one of the few exceptions to the rule. What linspace does is it says, okay, the first parameter is saying the number you want to start with. The second parameter is saying the number you want to end with. But this time the second parameter is indeed inclusive. It is indeed inclusive. Why? Because the whole point of linspace is you want to get from one number to another number in certain steps. And you want Python to figure out for you what those values should be in between so that it grows linearly. This is fantastic when we're doing certain kind of simulations, like for MySpace in the financial world. If I'm doing certain stock simulations where I want the price to be one value, start at one value, and in certain days go to a certain value. I'm doing a certain kind of simulation. So for example, let's say I'm doing a simulation where I want the stock price of, well, right now Tesla's around 800 bucks, but let's say I want the stock price. I want to do a simulation where I'm assuming the stock price is going from $800 to $1,000 a share for Tesla in 30 days. All right, 800 to 1,000 in 30 days. So basically, what I would do is for the first value, I'd put in 800. The second value, I'd put in 1,000, and the third parameter would say 30, and it would figure it out for me. Linspace would incrementally grow the stock price in even spaces and at an equal rate, not equal rate, at an equal number, at an equal increment until it went from 800 to 1,000. So here, that's what linspace does. So linspace is a very nifty little function for people doing certain kinds of simulations. So what do I call that? I'll call it z equals np dot linspace. And that is why I can go from 0 to 5 in 5 steps. I want to go from 0 to 5 in 5 steps. And that's why, oops, I didn't run it. And that's why z is going to be 0, 1.25, 2.5, 3.75, and 5. You'll see it figures out the math mathematically. It's growing by 1.25 from 0 to 5 to get to 5. And that is why this is one of the exceptions to the rule. Here, 5 will be inclusive. And that's why I showed you this function. One, it's a nifty little function to know. Two, it's an exception to the rule. It's an exception to the rule. All right? An exception to the rule. Back to arange. Now, what I haven't showed you in arange is how we can customize it a little bit, right? We can start from any number. What value is that? W. I can go from arange. We can go from 3. We're going to start from 3. We're going to go up to, but not including 7. And instead of in steps of 1 or steps of 5 or steps of 2, I can go small. Steps of 0.05. Type that in. And now, boom, to your side, you can see all these values. It's stepping in. Oh, actually, that's too big. Let's do 0.5. Too much to see there. Boom, that's easier to see. And as you can see, we went from 3 to 3.5, 4 to 4.5, 4.5 to 5, 5 5.5, 5.5 to 6, 6 to 6.5, and we stopped. Why? Because the next number would have been 7. And arange follows the normative rules, where the second parameter is always going to be exclusive. Exclusive. That's how these functions work. Linspace was the exception. Linspace was the exception. And let's see if I show you guys. Do I show you guys this? Yes, fantastic. So now I get into the whole data type things again here. But here in the next slide, if I'm missing parameters, so let's say I have W2 equals np.arange. Arange has default. So let's say I did 3, 7, and now I don't have a third parameter. Right? I don't have a third parameter. Arange, if you don't give a third parameter, it assumes 1. It assumes that you want to move from 3 to 7 in steps of 1. So that's why W2 would be 3, 4, 5, 6. Okay? Likewise, let's say I just had np.arange, just one number, 7. If you just have one number, what happens here is arange assumes that one number is what you want to go up to, not including it. So it will assume you're starting at 0. So, right, your starting point would be 0. And it's assuming you're stepping in increments of 1. So W3 will end up being the value 0, 1, 2, 3, 4, 5, 6. 0, 1, 2, 3, 4, 5, 6. Okay? 0, 1, 2, 3, 4, 5, 6. Fantastic. Fantastico. 0, 1, 2, 3, 4, 5, 6, right? So the values are 0, 1, 2, 3, 4, 5, 6. And now we could jump into arrays keeping their type. I gave you this example before. We're going to do it again. So here, let's create the array D. The array D is going to be np.arange 5. So what's this going to create? Let's do this one first. Slide this up. All right. So D will be 0, 1, 2, 3, 4. Okay? Because we're starting with 0, going up to not including 5, and we're stepping in. We're doing in steps of increment 1. We're incrementing in 1. Right? So D is 0, 1, 2, 3, 4. All right. Now from here, let me just copy this part right here. So D is 0, 1, 2, 3, 4. All right. D is 0, 1, 2, 3, 4. From here, so let me just uncomment this so you can see it clearer. So this is D right now, right? And so now what we want to do is we want to set the second value of D to 9.7. Now you guys already know what's going to happen, right? If D is of type integer and I try to change the second value to be 9.7, what's going to happen, guys? We've already been through this. The second value will now be, D will now be overwritten to be 0.9234. So the second value, they dropped the decimal place and it took it as 0.9234. Okay? Now, it's pretty straightforward. But here now you might get confused. What if I were to do E equals D times 0.04? Let's say we did this. Right? Is it 0.04? No, 0.4. Okay, 0.4. All right? And now what's going to happen? See, ladies and gentlemen, what happens now is just like in my ABI students, just like in R, when we have a single equals, there's an order of operations. You do the right side and then the left side. Same thing applies with Python. Same thing applies with Python. So here, when we do d equals times 0.4, let me go ahead and process this. What you see is d times 0.4 will generate an array like this: 0, 3.6, 0.8, 1.2, 1.6. Why? D is of type integers, but when we multiply by a float, why is the result coming back as all floats? Should it not be just dropping the decimal places? No, because now we are doing vector mathematics, which numpy allows us to do. We are doing vector mathematics. And now, like we did before with the example I showed you with the lists, we can do vector mathematics now. Just like we did in R, we can do it in Python. So for those of you that haven't taken any R and are new to programming, what's going on here? Well, D right here is a data container, right? Is D. When you do D times a number, what the hell does this mean? Or D plus a number, or D minus a number, right? Hypothetically, if I do D minus a number, or D plus a number. D is a numpy data container. What the hell does that mean, right? What happens is, both in R and numpy, it's like, I understand what you want to do. You want to multiply every value in D by 0.4, okay? Or for here, you want to subtract every value in D by 0.4. Or here, you want to add every value of D to 0.4. That is the heart of what vector mathematics is, guys. That is the heart of what vector mathematics is. Now, back to the data types, okay? If that's the case, so this number right here is going to give you 0, 3.6, basically what's in line 132. For 135, it's going to give you negative 0.4, 8.6, 1.6, 2.6, 3.6. Again, you have decimal places. And over here, it's going to give you 0.4, 9.4, 2.4, 3.4, 4.4. Decimal places. What's happening? Why is it that D, when we do vector mathematics, the data types are changing? It changes with whatever the data types are necessary. Because what's happening here is, when you do vector mathematics, it basically bumps up the memory that is needed to do the vector mathematics. So for here, for line 34, if I need to multiply 0.4 by every element of D, even though every element of D is an integer, because of the fact that one of my numbers in my vector mathematics is a decimal place, is a float, everything will be bumped up to a float. Remember this for vector mathematics, guys. You see here in line 128, we weren't really doing any kind of vector mathematics. We were just changing an existing array, right? And that's the key. When you do vector mathematics, you are theoretically creating a new array. So D stays as an integer. The values of D are not changing. The value of D's are not changing. D is still D. D still has its values, 0, 9, 2, 3, 4, and it's still of type integer. What happens is, when you do vector mathematics, you are creating a new array. And because you're creating a new array with the use of vector mathematics, it allows you to use whatever data types you need or want. And that is why when you have vector mathematics, in this case, in the example we do in line 131, the decimal places are preserved, and you get a new type of, and here now we can finally do the left side. We can do E equals D times 0.4, right? And we have a new array called E with these new values, 0, 3.6, 0.8, 1.2, 1.6, because E just became whatever that temporary new numpy array was being created, which was multiplying 0.4 times the values of D and making everything a float. So that's why E is now 0, 0.3.6, 0.8, 1.2. It has these values in line 132. This is the thing of vector mathematics. So the recording, sorry, so the numpy array creates the vector mathematics creates a whole new numpy array. That's going to be these decimal places, okay? And that's why that will work. That's why E is going to have decimal places, and it won't cut out the decimal places. All right. Oops. 1 second. So back here, to give you this example again, the right way, hypothetically, let's say when we create np.arange, if we wanted to create a numpy array on the fly that was of type floats, we can put an additional parameter in arange that we haven't used before, where we actually explicitly choose the type of data type. In this example right here, I'm doing the same thing as I did before, except this time I'm explicitly stating there's a new parameter I'm throwing in, data type, and I'm setting that equal to np.float, numpy.float. Right? We don't have to put the 32s or 64s or whatever. NumPy will figure it out for us. Right? And this now, I'll call this D2. D2 now will equal just like before 5, but this time I will say dtype equals np.float. Right? And now dt, if you look at it, how it's written, you'll see that dt actually is the same way it was before, but now you have the dots there. Those dots symbolize the fact that you have a float, your float on your hands. And now if I do that, run that line of command before, instead do it for D2 instead of D, right? And now what D2 is the same thing as before, but now it has a 9.7. It has a 9.7. So that's how you can explicitly create a float if you need it. Another way to do it, guys, by the way, is I'll create D3 equals, and this is actually a slightly more easier way to do it. I can just do 5 dot. I don't even have to put 0 in there. If I just put a float number in there, then D3 automatically will be of type float. And again, the operation from line 140 will work flawlessly, right? So you could do either 138 or 143 when you want to create a float. Obviously, you guys know my choice, which one's easier to do. It has less typing in it. Oops, sorry. And now, ladies and gentlemen, we will go back and we will do our vector mathematics again. All right, our vector mathematics again. So this time, I'm going to create A will be, I'm going to recreate the values we tried creating before with the list. I'll use arange to do it. So I'll do A np.arange. I want it to be from 1 to 3, right? I want it to be from 1 to 3. That is why, ladies and gentlemen, I do up to 4, because remember 4 is going to be exclusive. So A is 1, 2, 3. B is I want it to be 4, 5, 6. So B will be from 4 to 7. And this is how I'll get 4, 5, 6. It'll start at 4 and it'll end at 6. And now I have 4, 5, 6. And now, ladies and gentlemen, when I do, now my ABI students, when I do A plus B, what is C going to be? C is going to be 5, 7, 9. The answer you originally thought was going to be. So this is what NumPy allows you to do. NumPy allows you to do those vector mathematics. Alrighty. Sorry, I keep going to the wrong terminal. Okay. So vector mathematics, when you have a container plus a container, it does it by the dimensions. The first element plus the second element plus the third element, etc., etc., etc. All right. Likewise, I already showed you that if it's just a single number, right? If it's just a single number, for example, we have A already, and if I do A plus 5, A plus 5, right? It's just going to add 5 to every element of A, right? So we can add a single number, we can do math with a single number to a container, or we can do a container by a container, right? But what we cannot do, and here's the difference between R and Python. In R, well, in NumPy, if you do container math from a container to another container, the dimensions must be exactly the same. In R, ABI students remember, it wasn't the case. R would give you a warning, but it would still give you an answer. It would still crunch the numbers by repeating the smaller, whatever the smaller the data container is. NumPy array does not mess around with that. And some of you guys like that because it makes your exam so much more simpler. It does not mess around. If the dimensions, if it's a container on container mathematical calculation of some sort. If the dimensions are not exactly the same, it's an error. It's an error. You will get an error. Whereas in R, you will get a warning, but you will get an answer. In NumPy, you will get an error. Okay? So this concludes our introduction for the first day of class. And we did a brief summary on list and NumPy arrays. I went kind of fast with list. NumPy arrays, I guess I went kind of fast because we'll do more with NumPy arrays throughout the semester because we mess around with NumPy array, series, and pandas. It's basically NumPy array, series, and pandas. We're definitely going to pick up NumPy again when we do our classifiers, but I'm going to go ahead and move ahead with the series and then pandas on the next slides. All right. So hope you guys hope this video was good. This concludes part B of our intro, and I'll see you guys on the next video. Bye-bye.